Okay, welcome to the lesson on adding vectors using the component method. The components of a vector provide the most convenient and accurate way of adding or subtracting any number of vectors. The illustration below shows vectors a and b and their resultant vector c. In addition, the x and y components of each vector have also been shown. So here we have an illustration where you have two vectors added together, vector a and vector b. So you have vector A here and vector B here. They're added together using the tail to head method, and then the resultant vector is vector C, drawn from the start of the first vector to the finish of the second vector. Now, in order to find the components of vector C and the x and y components, we need to break up vector A and B into components. So the x component of vector A is here, and the x component of vector B is shown here. The resulting vector C, the x component of vector C, is ax plus bx. So it's the x component of A plus the x component of B makes up the x component of C. And similarly, the y components can be added together. So the y component of A can be added to the y component of B. So AY plus BY gives you the y component of vector C. So you have CY and CX. So we simply break up the components and of the two vectors we're adding together and add the x components together and the y components together to get the resultant components for vector C. So then we have Cx and Cy. Each of the x components of vector A and vector B have been added head to tail to give the x component of the resultant vector. Similarly, each of the y components of vectors A and vector B have been added to produce the y component of the resultant vector. As a result, we can make the following mathematical statement. The x component of vector C is equal to the x component of vector A plus the x component of vector B. And similarly, the y component of vector C is equal to the y component of vector A plus the y component of vector B. Using the mathematics of the Pythagorean theorem, the magnitude of C can then be found using the following equation. C is equal to the square root of cx squared plus cy squared, the x component of c squared plus the y component of c squared. And the angle theta that C makes with the x-axis is given by theta equals arctan cy over cx. So here's an example question. A jogger runs 145 meters in a direction of 20 degrees east of north, and then 105 meters in a direction 35 degrees south of east. Determine the magnitude and direction of the resultant vector C for these two displacements. So the first step is to draw a sketch of the diagrams. So we start with the first vector. It says a jogger runs 145 meters in a direction 20 degrees east of north. That is vector A. So we sketch the north, east, south, west compass on our graph paper. And then we measure 20 degrees east of north. So we start at north and measure 20 degrees. And then we draw our vector. That's vector A. And then vector B is this one. It says 105 meters in a direction 35 degrees south of east. So you have to draw this using the head to tail method. And so the next vector is going to be drawn at this location, at the head of the first vector. And so the easiest way to do this is to draw a second compass at this location. And then it says 35 degrees south of east. So here's east. That means we're going to go 35 degrees south of east. So we go 35. So this angle is 35 degrees. And then we draw our second vector. And then it's just a sketch. So it's not going to be perfectly accurate. We will eventually get to drawing scaled drawings, which are going to be very accurate, but for now it's just a sketch. So the distance that this runs is not going to be completely accurate, but it gives you a rough idea. And then our resultant is going to be drawn from the start of vector A to the finish of vector B. So this is vector C, A, and B. So drawing these sketches is one of the most challenging parts, but it's really important that you start with the sketch. So the sketch looks something like this. And once you draw your sketch, then you are going to break up the vector A into X and Y components, and you are going to break up vector B into X and Y components. So you just draw a right angled triangle for vector B, shown here, and you draw a right angled triangle for vector A, and that becomes the components of the vector. Then we have a bit of math involved in finding the resultant x and y values for vector C. So the x component of vector A is 145 times sine 20, which equals 49.6. The x component of vector B is 105 times cos 35, which equals 86. If you're not sure how I got these values, you can call me over and I can help you to understand that. And then we can find the resultant Cx value by simply adding Ax and Bx together. And that gives us the resultant Cx value. We do the same thing for the y components of each vector. So we find the y component, it's simple trigonometry. We find the y component of vector A, and we find the y component of vector B. Now, one of the really important things here is to pay attention to negative signs. The math, when you do the equation, will not produce a negative sign where you need it. You have to go back to the drawing and look to see if any of the components are negative. You can see here, for example, for the A vector, AY is positive because it's pointed upward. AX is positive because it's pointed to the right. BX is positive because it's pointed to the right. However, BY is negative because it's pointed downward. So you have to include a negative sign for BY. You have to put that in. And then when we add AY plus BY, we are essentially subtracting them. So it's 76 meters. And you can see that from the diagram. Vector A is pointed upward and vector B is pointed downward. So their y components subtract from one another to find the y component of vector C. So CY equals CA minus, or sorry, CY equals AY minus BY. And you can see here that the X component is equal to AX plus BX because they're both pointed to the right. So the math just reflects that. And then we can use the Pythagorean theorem to solve for C. So this square root sign extends to the entire equation. So square root cx squared plus cy squared, which equals square root of 135.6 squared plus 76 squared, which equals 155 meters. And then we can calculate the angle. And using the diagram, we can see that it's 29 degrees north of east. From the equation, we get 29 degrees, and from the diagram, we get north of east. Okay, that concludes the presentation. You can try the practice questions.